All right, guys, last week you did a chocolates task where you learned about a new type of equation for your 8th grade year that you have never had to solve before. And it's not that different, but there is one very important key difference that we need to make sure we understand. So today you need page 46, looks like this. It's called Solving Equations with Variables on Both Sides. Get out page 46, get out your pens and your pencils. Here we go. To bring it back just a little bit first to like what you were doing with the chocolates task. On the chocolates task, some of you drew models, drew pictures of what you were looking at. Here's a bag of chocolate, here's a loose chocolate. That's very similar to algebra tile models that we have here, okay? So just like on Friday when you had like, okay, these are my bags and these are my loose chocolates. These right here are what we call X tiles. Those can be like your bags of chocolate. So we have 1, 2, 3, 4, 5 of them on this side and 1, 2, 3 of them on this side. And those tiles there are to reflect what's happening in this equation right here. Those 5 X tiles go along with 5X, and those 3 X tiles go along with 3X. Just like we have bags of chocolate here, we also have loose chocolates. And these are just our 1 tiles. Notice I have 2 of them here to go along with that constant value of 2 in this equation. And you guessed it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them over here. Well, lots of you recognized on the chocolates task, if you had one child, one person that had 1 bag of chocolates and another person that had a bag of chocolates, and we knew that that was the same amount of chocolates, we could cancel it off of each side of the equation and not have to really calculate it into our calculations. Because if it was even on both sides in an equation, you can kind of cancel those even things away. Likewise here with this model, if I have 5 X's and 2 1s over here, and I have 3 X's and 12 1s over here, I can cancel what's even here. I can balance it out by saying, okay, these 3 tiles are going to cancel with the 3 over here that are the exact same size. We just zeroed those out is what we did. We turned them into 0. They don't really cancel, they just zero away. They turn into 0. Likewise, we can say, okay, these 2 will zero out with these 2. And then we can look at what we have left. So over here on this side of the equation, we have 2 X's left. And I'm going to write the original. And I'm going to show algebraically what's going on with the algebra. This says show the algebraic steps. So let's look at what's going on with the algebra compared to what's going on with crossing things off here, just like you did with your chocolates task. So what we did over here is we canceled off 3 X's. We took them away, which is subtraction. That's really what we did on that side is we subtracted 3 X's. And we canceled the exact same amount over here. Okay, so he said, all right, I'm going to cancel 3 X's and cancel 3 X's. And why 3? Well, because that's the amount that both sides have. That's the amount that can be zeroed out on both sides. So what happened here is these ones turned to 0. These ones didn't, and we're going to look at what's left in a second. But the other thing we did is we said, I'm going to cancel out 2 1s on each side. Now I want you to notice when that happened, what happened here is the X's zeroed out on this side and the 1s turned to 0 on that side. And now we just are going to look at what's left. We have 2 X's in our picture here, but also algebraically, that's exactly what would happen. 5X minus 3X is 2 X's left in our picture. We don't have any 1s left on this in this model, and that's because those 2's turned into 0. On this side, we have 2, 4, 6, 8 left. 10, there's 2 more up there too. 2, 4, 6, 8, 10 left, which makes sense algebraically because 12 minus 2 is 10. And now this is like when you guys were looking at your chocolates yesterday and you went, okay, well, if 2 bags is equal to 10 loose chocolates, that's 5 chocolates in each bag. And that's really because you did this. You did division. Each one of those X's is equal to 5 of these 1s. The new thing this year in 8th grade math is that you have to be able to solve equations with variables on both sides. And the only difference here compared to what you did last year with solving equations is that that means you now have to zero out some variables. That's not something you did in 7th grade, but it's something you have to do now. It's not that big of a stretch. Everything else you know about solving equations is exactly the same. So to make sure we're really clear on that, let's take a look at these two equations right here. They look almost the same. Take a look at them for just a minute on 1 and 2. They look almost the same. The only difference is where that equal sign is, and that actually changes things quite a bit, okay? So we're gonna write over here, there are two options that you could have. You could have variables. If the variables are on the same side, you need to know that those can just be combined. If the variables are on the same side, then you are going to combine them. I'll put this in a box over here. If the variables are on the same side, and when I say same side, it's the same side of the equal sign, okay? If the variables are on the same side of the equal sign, you're just gonna combine them. But if the variables are on opposite sides, and that's opposite sides of the equal sign. Okay, if the variables are on opposite sides of the equal sign, then you have to zero one out. And I'll show you what I mean by that in these examples here. Okay, so let's go through these examples and let's see how this works. So right here, here's my equal sign. If you recall from last year, years past, sometimes it's really helpful to draw a dashed line like that and just show yourself we have the left side of the equation, we have the right side of the equation. So the question here is, I see two variables. Actually, I see one variable. It is the same variable. It's just in two different places. So, and that variable, are those variables on the same side of the equal sign, or are they on opposite sides of the equal sign? They are on opposite sides of the equal sign. Versus this one, number 2, if I put my dashed line there and clear it out for my brain, here's my two sides to the equation. On this one, are my variables on opposite sides, or are they on the same side? They are on the same side. So this problem goes with this. If the variables are on the same side, you can simply combine like terms. Because they're on the same side of the equation, when I teach this to my 7th graders, I just call it cleanup. It's your cleanup, right? You're not doing something to both sides, you're just cleaning it up. So for this equation number 2, we're gonna go 4x plus 2x, because they're on the same side, put them together, and we're gonna get 6x equals 12. And then we're gonna go divide by 6, and x equals 2. Why did I divide by 6? Because that part's the multiplicative inverse, okay? If it's stuck to the variable and they are multiplying, then your job is to turn it to 1, divide it off. Remember, do the inverse operations from last year. Now, this one, number 1, that's different. Okay, so I have to go, I cannot combine those because they're on opposite sides of the equation. So now I have to do like I was doing up here, and I have to cancel. I have to zero out some x's. Now, the question is, which one do you zero out? And the answer is whatever one you want, but do the one that's going to make your life easier. If I zero out 4x and bring it over here, I have now moved everything to the same side of the equation, and that's weird. So instead, I'm going to go like this, minus 2x. I just did an inverse operation on one side, so I absolutely have to do the same inverse operation on the other side. This is the only new thing this year, is you'll have variables on both sides and you'll have to zero one of them out. So that turns to 0. Now I have 2x equals 12. 4x minus 2x is 2x. I'm going to divide by 2, x equals 6. So moving that equal sign completely changed how I solved this. And this is the part that's new this year. You'll have variables on both sides of the equation. Let's try this again. Here we go. 3 and 4. Do you see variables on both sides of the equation? I see variables on both sides of the equation. So when you have variables on both sides of the equation, you have to decide which one you're going to zero out. Would you like to zero out the negative 4x, or would you like to zero out the 3x? And I'm going to tell you right now, it does not matter. Sometimes when I see a negative, I like to zero that one out because then it's going to make it a positive, and sometimes we're better working with positives. So I'm going to choose to zero out this one. If I do it on the left-hand side, I need to come over here and do it to the right-hand side as well. I just turned that into 0. Now this says 6 equals 7x minus 36. This now looks like a basic two-step equation from 7th grade. Now I need to clear this number by adding 36 to both sides. So I zeroed out one of the variables, then I zeroed out one of the numbers. 42 equals 7x, divide by 7, divide by 7, x equals 6. Most of this stuff is not new. The only new thing is right at the beginning you have to say, are there variables on both sides? Because if there are, I need to zero one out. Variables on both sides. I need to zero one out. Do you want to zero out this one or this one? I want to zero out this one. You really can choose, and it's fine either way. Then I'm going to come over here and write plus 2.2x. I zeroed out the variable over here. Now I have 0.9x minus 0.6 equals, don't forget to bring that negative 0.42 with it. Now I'm going to zero out the number. I'm going to say that one more time. Up here, I zeroed out one of the variables. Now I'm zeroing out one of the numbers. It wouldn't make any sense to zero out the 0.42 because it's already on the other side. We're trying to isolate the variable still. 0.9x equals 0.18. Now divide by 0.9, divide by 0.9. At any point, if you need a calculator for this, you can grab one. I know it's 2.2 or 0.2. Variables on both sides. That is the only new thing today. All right, I want you guys to pause me right now and try out these last 4 questions. See if you can solve them. Go ahead and pause me, give them a try. Okay, let's see how you did. Variables on both sides. You might have done this differently than me, but I am going to zero out 1/3 x and 1/3 x. So now I have negative 8 equals 12 plus 4/3 minus 1/3 is 3/3, which is just 1x. That worked out nicely. Minus 12 minus 12, x equals negative 20. I'm just going to keep going. You keep watching and fixing any mistakes you might have made. Negative 1/2 is like negative 0.5. So I'm going to add 0.5x, add 0.5x. I'm zeroing out a variable. So now I have 3 plus 0.25x equals 9. Zeroed out a variable. Now I'm going to zero out a number. 0.25x equals 6. I zero out one of the variables and then I zero out one of the numbers. And notice if I zero out a variable on the right, I'm zeroing out a number on the left and vice versa. Divide by 0.25, divide by 0.25. 6 divided, oh, it's going to be 24 because it's like times by 4. 24, x equals 24. If you have any questions about these or you didn't get to these, please let me know. Whoa, lots of cleanup here. Look what I have to do first. Okay, here I go. I'm going to distribute right here 7x plus 14 minus 4x. I'm going to distribute right here 2x plus 10. Remember distributive property? These variables are on the same side. Same side. So what do I do if they're on the same side? Just combine them. 3x plus 14 equals 2x plus 10. Now I am ready to go. Zero out a variable. That gives me 1x plus 14 equals 10. Now zero out a number. X equals negative 4. Okay, last one. The bell's gonna ring really soon. It's gonna be loud. 10x plus 2x minus 10 equals 18x plus 26. Combine like terms because those are on the same side. If they're on the same side, combine them. 12x minus 10 equals 18x plus 26. Here I go. I'm going to zero out this variable just because I don't want a negative variable. And then I'm going to get negative 10 equals 6x plus 26. Zero out this number. Negative 36 equals 6x. Divide by 6, and x equals negative 6. Most of this is stuff you've already done. The only difference today is zero out a variable first.